My name is Rajiv Roopnarine, and the engineering skills that I bring to this team are that I am hardworking, well-versed in SolidWorks simulation and report writing. I was also an acting member in the Environmental Action League, so I bring a wealth of knowledge in terms of environmental management to the table.
I'm also good at software design and I do well in hand calculations. I also added to the video editing to this project.
My name is Lee Mclean from G6 Engineering. The engineering attributes that I bring to this team are good organizational skills, good report formatting, and good analytical skills.
And that we won't do it for less than $5 million. Hi, my name is Omar Mohammed, and the engineering skills that I bring to this team are leadership skills. I'm very tenacious, SolidWorks design and analytical calculations, and I don't just work hard, I work smart. And welcome to our presentation.
We begin our presentation with some background information on glass. Glass bottle usage goes back as far as 100 BC. In 2018 alone, the world used an estimated 58.62 million metric tons of glass bottles, with the global trend increasing upwards in the future. Currently, over 40,000 tons of unrecycled glass enters our landfills in Trinidad and Tobago every year. The materials used to make glass are approximately 70% sand, along with a specific mixture of soda ash, limestone, and other natural substances. Soda lime glass, which is used in glass bottles, is 100% recyclable. Cullets melt at a lower temperature, which reduces energy consumption and requires fewer raw materials. The finer the cullet, the less energy required to melt it. Recycling these glass bottles can save carbon emissions and energy consumption, leading to a reduction in our carbon footprint and the cost of the final product. The problem that we face is that as the globe continues to produce and use more and more glass bottles, the need to create a more efficient glass bottle recycling system increases so as to maintain green manufacturing guidelines. Our aim for this project is to design a glass recycling machine that will separate, wash, and pulverize glass bottles, giving fine glass cullets as the final product. The objectives that we hope to achieve in this project are as follows: to transcribe a literature and patent review to aid in the conceptualization of the design, to conduct research and surveys to determine the client/user requirements, to undertake the design process to generate 3 designs, rate them, and select the best one to further develop, to perform the analytically based calculations and simulations on the proposed machine, to construct a prototype based on function to mimic real-world action. To gain a better understanding of the glass bottle, a literature review was conducted. It was found that the first patent of the modern English bottle was granted to John Colnett on the 10th of April 1661. Typically, the ingredients for making glass are soda ash, disodium carbonate, sand, silicon dioxide, and limestone, calcium carbonate. These are subsequently mixed and placed in a furnace to melt. The resulting molten mixture is liquid glass. The main process for glass bottle manufacture is blow molding. Blow molding is a process that converts a hollow porcelain or preform into a shaped container by deforming it under air pressure against a mold. Blow molding processes involve shaping the material while it is in a molten state, but the melt has cooled enough so that the viscosity is still quite high. A glass cullet is produced from crushing waste glass collected in municipal and industrial waste streams to a uniform size. Using cullets in glass making saves energy and reduces costs. It was also found that there is a need for color-based sensors in modern glass cullet producing machines so that manufacturing companies can more efficiently produce their products. 5 patents were reviewed to gain inspiration for our designs. Patent 1. This device comprises of a spinning blade and cowl, a disposal receptacle, and an internal screen. It is a simple trash bin-like device where the user disposes the bottle into the rubber diaphragm at the top, and the spinning blade crushes the bottle into a fine powder. Glass and paper are separated by the internal screen based on volume to allow for easy green disposal. This device, however, is more suited for residential use than actual industrial use. Patent 2. This device comprises of an impeller crusher, saw blades along an eccentric shaft, roll forming machine, spray nozzle, conveyor belts, and an oven. The glass is first melted into a glass film and then slowly cooled by the spray nozzles to avoid shock. It is then placed onto the impeller crusher and further broken down using saw blades. By melting the glass first, it is theorized that the crushing process would give a more uniform particle size. However, melting glass wastes plenty of energy when a simple screening device could have been used instead. Patent 3. This device comprises of pulverizing rolls, a jaw, flywheels, magnetic conveyor belts, and a vibrating screen. The glass or metallic can is disposed onto the top orifice and the jaw crushing it with the pulverizing rolls, further reducing the size of the cullet. These fragments then pass through the magnetic conveyor belt where ferrous materials are attracted to it. The aluminum pieces are then separated by an eddy current. Since aluminum is not magnetic, the remaining glass cullets are then collected into the bin. This machine's capacity, however, like the first, is more suited to a restaurant than a commercial plant. Patent 4. This machine comprises of a surge hopper, a chain mill, a trommel, watering beds, conveyor belts, a drying bed, a ball mill, and a vacuum. The bottles are dumped into the surge hopper, crushing it and screening by the chain mill and trommel respectively. The granules are then passed through a waterbed where the paper and other impurities from the glass will simply float to the top, whilst the heavy granules will sink to the bottom. The granules are then dried and placed into the ball mill where they can be further refined into a fine powder consistency. A vacuum then sucks up the dust and places it into the bin. For the design specifications, additional refinement of the cullet is not required. Patent 5. This invention comprises of an ozonation bed, a trommel, flexible impactors, a saw blade pulverizer, an optical sensor, an eddy current separator, a blower, and magnets. This invention focuses on an efficient and clean method to produce the cullets, using ozonation to clean the bottles. Ozonation is simply ozone from the atmosphere being dissolved into the glass. It cleans the glass from any biological impurities. The invention also uses flexible impactors to remove the labels, eddy currents, magnets, and blowers to remove the aluminum, ferrous, and other particles respectively. Additionally, it incorporates an optical sensor which can separate the cullets via color. This process may be improved by the incorporation of a more efficient crushing process, as saw blade pulverizers are not the most efficient in terms of crushing. Now to introduce a special guest who will discuss his client/user requirements.
Hi, I'm Ronald Roach, the CEO of the Trinidad and Tobago Solid Waste Management Company Limited. In terms of our client requirements for a glass pulverizer, we're looking for something that is energy efficient, that has low carbon emissions, that has a fine particle size, that is low in maintenance, especially maintenance related to the replacement of the blades, that has a high capacity, that is provides a high degree of automation, and of course that is inexpensive to manufacture.
To meet our clients' requirements, we have created design specifications to ensure that the machine design complies with the criteria set out. Firstly, the machine must not have limitations on the size of glass bottles it's able to crush. The machine must also have a production capacity of at least 10 metric tons of bottles a day. Since the machine is being designed for a small recycling company, it should not exceed 5,000 square feet. The machine must include a washing component to remove impurities and bottle labels before being crushed. A function must be included to separate the bottles by color. For safety purposes, the machine must be equipped with face guards and an emergency stopping system. Standard parts must be used to allow for easy inspection and maintenance. The machine must have good stability and support to minimize vibrations. A black box shows the functional decomposition of a machine by representing its inputs and outputs in schematic form. We can see here that glass bottles, an acidic solution, and electrical energy are inputted to the machine. After the machine performs its functions, it outputs clean glass cullets, a dirty water solution, and heat, sound, and vibrational energy. A transparent box shows the subfunctions of the machine to be designed. While the main function of the machine is to pulverize glass, it must also convey, wash, and dry glass bottles, along with separating particles based on size and color. Here we see the inputs and outputs of the subfunctions. This takes us to our functions means tree. This chart analyzes the primary and secondary functions of the machine to be designed and the means by which these functions can be carried out. The functions are shown in the trapezium-shaped boxes, while the means are shown in the rectangular-shaped boxes. The chart starts at the top with the main function, glass pulverizing. 3 ways of carrying out this function are proposed, namely roller crushing, laser grade cutting, and hammer crushing. The third level of the chart contains functions which must be carried out in order to successfully complete the proposed means. Overall, there are 5 levels of functions and means shown in this chart. A functional analysis chart was completed to ensure an efficient and operative glass crushing process. The functions of the machine are set out in a logical flow with the inclusion of feedback loops. For example, the reintroduction of oversized grains to the crushing function is shown. In addition, subfunctions such as disposing waste are included.
Here are some key attributes that should be taken into consideration when designing the glass pulverizer. It should be energy efficient, as well as user friendly, low maintenance, inexpensive to manufacture, high capacity, safety, and also environmentally friendly. Now from this table we can see the key attributes mentioned before and the metrics to give us a better understanding of each attribute. Now in this table each attribute will be compared to one another. Now looking at each row, one would see that environmentally friendly would be most important in building this glass pulverizer as compared to the other attributes, and this would be due to the fact that this whole operation is based on recycling and saving the environment. Here we have a morphological chart. This chart deals with each process that is associated with the pulverizer and the options that is available in carrying out each process.
Conceptual Design 1. In this design, the bottles are placed onto the conveyor belt via an acid bath into the hopper. It is then crushed by the rotating saw blades, which pulverizes the bottles. The granules are then passed through the trommel, allowing the granules which are small enough to filter through, with the large granules being collected in a bin to be reintroduced into the machine. The cullets then pass through an optical sensor where it is sorted by its respective colors and then placed into bins. Conceptual design 2. The bottles are loaded onto the conveyor belt from an acid bath into the hopper. From this, the bottles fall into the spinning hammer mill, which pulverizes the bottles. The surrounding screen allows the fine granules to pass through. After this, the cullets are passed through the optical sensor where they are sorted via color. Conceptual design 3. The glass bottles are loaded onto the conveyor belt and are guided into a label remover machine. An acidic solution followed by water is sprayed into the bottles to remove the labels and wash the bottle. The bottles are then guided to a container which is heated via an induction heating pad. The heat from the container dries the bottles, which then prepares it for crushing. The bottles are then crushed via a mechanical power press, and the pellets are sieved through the bottom of the container. This is the table showing the concept ratings for all three designs. This is the table showing the design selection for all three designs. From this pew chart, we can see that design 2 is best rated, and thus design 2 was chosen as the final design. Description of final design. Main components: carrier arm, rotating hammers, rotating shaft, trommel, motor, conveyor belt, acid bath, optical sensor. Acid bath. A large container containing muriatic acid. Studies have shown that muriatic acid is fully capable of dissolving paper on its own, as well as removing any contaminants from the bottle. The bottle passes through the bath, which is the first step in the cullet making process. The bottles spend a predetermined amount of time to allow all the paper and other contaminants to be dissolved from the glass. The glass is then sent to be crushed. Crushing mechanism. The crushing mechanism is attached to the shaft, where it is secured at the ends by bearings. Comprised of the carrier arm and rotating hammers, which are connected via pins to allow the hammers to rotate freely. The initial hammer would impact the bottle with enough force, causing the bottle to break. The rotation, the arm, allows for the already broken pieces to be continuously smashed. Trommel. The trommel is equipped with a wide opening, dubbed the hopper, to allow bottles to enter into from the conveyor belt. The trommel is a cylindrical screen with fine holes whose size are predetermined by the client all the way through. The trommel, combined with the crushing mechanism, serves as a drying mechanism as well, where the rotating arm causes air to circulate throughout the glass, with drier atmospheric air passing through the trommel and onto the glass. After being pulverized, the glass granules will simply fall through the screen and onto another conveyor belt for further sorting. Optical sensor. Optical sensors send a light signal onto the object. The object then reflects the light incident to the sensor. The sensor then converts the light signal into an electrical signal. The sensor detects the color and transmits a signal to a PLC shifting mechanism, activated by a pneumatic valve, which pushes the cullets into their respective bins. Here's a list of all the references that assisted with our design. On behalf of G6 Engineering, thank you for listening.